Good day, my highly esteemed viewers, and welcome back to class. Remember, my name still remains Israel. Our video today is a continuation of the previous one we've already started. Remember, in our previous video, we gave you a table. Don't miss that table. If you have not studied it, study it properly, because those are the kind of table you may likely encounter. You will likely encounter. So today's video is on the calculations, and this is part A. Make sure you watch out for part B because it's not completed, but the question is complete. Now, solution A contains 0.500 mole per DEC of H2SO4. Solution B is 30.50 gram of CuCO3. That's copper 2 tetrahydrocarbonate 4 crystal. This water crystallization per DMQ. Titration result shows that 20 cm cube of A neutralized 25 cm cube of B. Calculate the concentration of B in mole per DMQ. Molar mass of copper 2 tetrahydrocarbonate 4 containing water crystallization. Percentage of water crystallization, that's this SH2O, value of S. These are the values it says you use, and this is the complete equation. So from this, you go straight to the calculation. Recopy the equation, and this is the equation. Then the mole ratio. You see, number of moles of H2SO4 is 1, CuCO3 is 1. I told you in my previous video, you don't have business with the products. Then applying the formula. There are two formulas you can use. You can use the one from first principle. You can use the one from direct formula. The one I'm using here is for direct formula because many of you says you prefer this direct formula. It's easier for you. None of them is hard. Both of them are easy. So Ca is 0.05 mole. You can see it. Number of moles. That's the mole per DN cube of H2SO4. Va 20.0 cm cube. They gave everything. Cb you are not giving. That's the concentration of base in mole per DN cube you are not giving. Vb volume of the base, which is 25. Va is 20. We've already said that. Then number of moles of acid or mole ratio is 1 to 1. You can see it, 1 to 1. Then you substitute. If you check, if you are confused, go to my previous video. I did a live practical, so many live practicals, and did the full calculations. Those one will make you to really understand it. But this one is equally very simple. But remember, these RGCs are based. Nobody will tell you to go to lab and do your work. He just gave you the values you are going to use. You only need to use this method and have your answers. 0.0500 times 20 over this. That's the substitution. You have substituted the values, mole ratio 1 to 1 based on this formula. Then you try to make CB the Stoichkov formula by doing it in this format. Then CB, which is the Stoichkov formula, will give you this. Then you calculate this. You have 0.04, which you have to make to 3 significant figures. This is 3SF. Remember this WAEC and ECHO, they go with 3 significant figures. If you leave your answer like this, they'll mark it wrong. We don't use decimal place, we use significant figures in practical chemistry. So that is how it goes. Remember, you must follow this pattern when you are substituting. This correct substitution, there's 1 mark for it. These are usually 4 marks, as I told you in my previous video. This one has 1 mark, mole ratio, another 1 mark, Stoichkov formula, 1 mark, then the evaluation, correct evaluation. You don't just say evaluation. You have evaluated it correctly, but you must make it 3 significant figures. Thank you very much for watching my video. Please watch out for the completion of the second video because of the size of the board. God bless you. Remember, help me to share, like, and subscribe if you have not been doing so. Let every other person benefit because there is love in sharing. God bless you.